Hi, everyone. So lunch is near. It's the second day of the conference, so I'm sure a bunch of you are tired and are hungry. So thank you for being here. And yeah, welcome to my talk about WebAssembly and cloud computing. Just one question before I start. Who was here? Who was listening to Nigel's talk just before me? OK, hi. So I think our talks are kind of the same, but we'll see. Maybe you'll learn something else, something new. So my name is Djordje Lukic. I'm a software engineer at Docker. I work in the runtime team, so I work on Docker, on the daemon, and on the CLI. And since last year, I've also worked on the WebAssembly stuff. And my co-speaker, Jorge, he's unfortunately not here. So I guess you're stuck with me today. But Jorge, yeah, Jorge is also in the runtime team. He's the Rust wizard, and he's responsible for all the new runtimes we added recently in Docker Desktop. Right, so let's start simple. Let's see if we can see what is WebAssembly. I think it's important to maybe understand what's WebAssembly, where it came from, and why is it so interesting these days. So WebAssembly or Wasm, I prefer to say WebAssembly because Wasm is kind of weird to say to me. So WebAssembly is a binary bytecode. So imagine the Java binary bytecode with the same write once, run everywhere promise, but then add 20 years of experience on top of it. WebAssembly actually started as an experiment to compile C code to JavaScript so that you can run your C code inside the browser. So that kind of explains the web part of the name. And then later, as time went on, it evolved to be a binary bytecode that's language agnostic. So today you have a lot of languages that you can use that can compile to WebAssembly. So yeah, WebAssembly, it's not a language. It's not designed to be written or read by humans, but by compilers. So that's kind of why we have the assembly name in the WebAssembly. Sorry. Oh, OK. Yeah, born for the web. So yeah, WebAssembly is born for the web. And that gives it some interesting qualities that I think are quite nice. So first, of course, we have security. WebAssembly runs in the browser, and in the browser we run a lot of untrusted code from third-party, a lot of untrusted third-party code. So you have to be able to run it safely. And also, basically, WebAssembly is basically like a glorified calculator. It can crunch numbers really well. And it can only do computations, so only WebAssembly can't interact with the external world. But then, on its own, that wouldn't be so interesting. So there are ways that you can add functions, host functions, that the runtime can give to the module, to the WebAssembly module, so that the module can talk to the outside world. And sorry. And of course, the runtime, with every WebAssembly runtime, you can have a very granular control over what you give to the module that it can interact with the world. The second one is performance. Performance is really also important on the web because browsers are pretty much everywhere in TVs, in low-end phones. So yeah, performance is paramount, and you always want things to be running smoothly. So WebAssembly is a quite compact binary format. And there's one cool feature about the WebAssembly format is that you can start parsing and compiling it while you're downloading it. So you don't need to wait to download the whole thing to start to compile it. And most of the runtimes will compile that to native code, so you will get near native speeds. And finally, size. No one likes 40 megabytes websites. So the WebAssembly bytecode is made to be, well, is a very compact binary format, and it also, you can compress it really well. So if you look at all those things, you can say, hey, I want to have the same in my cloud, or for any of my workloads. You want them to be fast, you don't want them to load quickly, and you want them to be secure. So does this mean that you need to now throw everything you have and start from scratch? Well, so yeah, basically the question is, so are we like in a big WebAssembly against containers battle? And I don't think so. I work at Docker, so I don't think WebAssembly is here to kill the containers. And if you think about it, when containers came in, so we had VMs, and back in the day also, everyone loves some drama, right? So they were saying, oh, containers will kill VMs. And we can see today that's actually not the case. And actually today you use VMs to run containers in. And you can also use container tools that will help you run a VM in which you will run a container. So basically, they coexist and work really well. And I think it will be the same kind of with WebAssembly. All the knowledge from the infrastructure code, from the infrastructure part, and the distribution part will help WebAssembly to be bigger. So yeah, WebAssembly, I don't think it won't replace containers, but it will enable new workflows for everyone. So I guess then the question is, when should you use WebAssembly, and when should you use containers? We tried kind of to give some tips about when you should choose one or the other. So WebAssembly is kind of nice for short-lived self-contained logic. So if you have some simple function that you can run, especially because most of the runtimes, their marketing will say, oh, sub-millisecond startup times. So if you have a cloud function, maybe you can try out WebAssembly and see if that works for you. One neat thing also about WebAssembly is that it's platform independent. So in the cloud now, today, you have AMD machines, you have ARM machines, and there's also RISC-V that's RISC-V that's gaining popularity. So if you want to run containers on all of those platforms, you need to compile for each of them. Whereas with WebAssembly, you can compile once, and it can run on all of those platforms. So this is true, but not always true. I was talking with someone who works on WebAssembly, and they told me there are some issues with some floating things, floating numbers, but it's mostly true. So, or at least I guess they will also fix it in the future. Next, so yeah, there's WebAssembly. At the core, it's very secure. It has this very secure sandbox. So if you need to run third-party code, maybe use WebAssembly. And for example, there is Shopify. Recently, I think it was this year, made it so that you can run your own plugins inside Shopify, and they run it as a WebAssembly module. And there's also, what's the name of the game? Microsoft what's the flight simulator? Microsoft Flight Simulator also switched to WebAssembly to run I think it's extensions for the game. And also, yeah, finally, if you look at Spin and if you see that they have a feature that you want to try out, that you need, just use them. And then containers, well, we know containers, so if you have a long-running process, maybe use a container. If you have a lot of interactions with the environment, like I said, WebAssembly on its own can't talk to anything, can't talk to anyone. So if you need to talk to a lot of different services, databases, file systems, it's still better to choose containers over WebAssembly. In the WebAssembly world, they're working on it, but it's not there yet, I think. And yeah, if you have already a solution that works for you, let's just continue using it, right? Right, so how does it all fit with Docker and Docker Desktop? So I did a talk earlier this year in Barcelona where I deep dived around it, but I didn't want to redo all of the things. So if you look on YouTube, you can find it. But basically, what we've done is, so yeah, you have Docker Hub, you have your container image that you know. You can then use Docker and run your container. And with the work we've done, you can now do the same with WebAssembly modules. So you can package a WebAssembly module in a WebAssembly image, I guess, and then Docker can pull it and run your WebAssembly module. That's kind of like overly simplified overview of how it works. But it's not that simple. So yeah, how can you get started today with it? Well, with Docker Desktop, it's quite simple. You go into the settings. You have two checkboxes that you need to enable. One is for the using containerd for pulling and storing images, and the other one is enable WebAssembly. So if you enable WebAssembly, what it will do is it will download all of these runtimes. These are, as of today, I think the only runtimes that exist and that have shims for it. A shim is a way for Docker. So shim is like a program that Docker uses and gives the image, and then the shim will run the image. So basically, yeah, today we have these 7. So spin from Fermion, slides, and I mean, you can read all of those. And yeah, basically, last week we released the 4.24 version of Docker Desktop, where we added the Lunatic one and the Wasm worker service one. So why do we have that many different runtimes? Well, first, because having a choice is nice. And also, they are all not really the same. So I kind of split them into two. There are the bare runtimes. A bare runtime, you give it a module, and it can run it. And then that's it. So those are like the Wasm time, Wasm edge, and the Wasm ones. And then on the other side, you have things like spin and slide, which are more like framework runtimes. They do run a WebAssembly module, but then they add on top of it things like spin. In spin, for example, they have HTTP triggers, Redis triggers, and also recently, I think there's some AI goodness in there. Then there's slide, which is kind of the same. The WebAssembly, the WWS, is a cool one. What they did is that they compiled the language itself into a module. So they compiled Python into WebAssembly, and then they give to that module your Python code, and then it can run. I'll show it to you. It's kind of nice. And finally, there's Lunatic. We put it in a framework runtime, but it's kind of in the middle. It can run WebAssembly modules, but they added a bunch of like Erlang-inspired concurrency model things. Check it out. I didn't have really enough time to play with it, but it looks cool. And we are off to the demos right now. Okay. Not this one. Oh, okay. I killed my item. Is this enough? Yep. Is it too much? No. OK. All right. Let me show. So the first demo I want to show is a simple Golang one. So if you look at what I have here, it's really, I mean, yeah, it's a small demo. I don't want to overcomplicate it. So it's a simple Go program. We say, hey, DockerCon, and I just print the current OS and the current architecture of So I can run this, for example, with Go. And it says, hello, DockerCon. And of course, my OS is Darwin because I'm on an OS, on a Mac. And it's ARM64 because I have an M1 CPU. And I think it was in Go 120 that they added the support for WebAssembly. Before that, you had to use TinyGo, but today you can also use Go to compile your program into WebAssembly. So let's see how to do that. The way you cross-compile in Go is that you define the GoOS and GoArch when you build. So GoOS in this case will be WASI P1, and GoArch will be Wasm. Maybe it's the other way around. Let's see. And then you say go build. Let's see. I will call it hello.wasm and dot. Okay. Okay. So we have a WebAssembly module now, and I think, yeah, no. Yeah, it works. And let's see, we can of course run this. Yay. The thing that changed here is that now it says, okay, my OS is WASI P1. WASI P1 means WASI Preview 1. And WASI is the WebAssembly system interface, which is like the thing that gives WebAssembly the ability to read from the file system, from the environment, and a bunch of other stuff. And the architecture is Wasm. So let's see how we can build an image with this module. Let me show you here. Where am I? Yeah. If I do this. Yeah, nice. So the way you build a WebAssembly image, this is one of the ways. So you start from scratch because the scratch image is an image that doesn't contain anything. So we start from nothing, and then you can copy your hello WebAssembly module inside the image, and then you say, okay, well, the entry point will be the module that I just put inside. And then to build, you just need to give it a platform, which is WASI Wasm, and give it a tag, and that will be it. But this isn't really fun because, I mean, you're building WebAssembly outside, and then you're just putting them inside an image. So at least I think it's better to also use Docker to build everything. And the way you do it, it's, well, kind of more involved, but it's not really that complicated. So the first thing you need, so in order to compile a Golang program, I need the Golang image. The platform flag here is kind of new. What it means is that as you saw, I'm building for the WASI Wasm platform, I need to tell to Docker, okay, when you pull the Golang image, pull the one that is for the current platform and not for the target platform, because Golang WASI Wasm image doesn't exist. So yeah, you tell it to pull the Linux Golang image, and then the normal, I need a work dir because Golang always needs a work dir. I copy all my code, and the same build command that I just did before in the terminal. And finally, again, start from scratch, pull in the module, and you say, okay, this is my entry point. Let's see how that works. So I have here my Docker file, and it's the same thing that you saw here. We're just kind of building it. So let's see, Docker build, -- platform, Wasm, DockerCon. Nice, it built. So I built my DockerCon image, and let's see if we can run this. So if I say docker run DockerCon, it will say, oh, I don't know what you're talking about. It tried to pull the image because it didn't find it. And it didn't find it because when you just say docker run like this, Docker will use the current platform. But my image doesn't exist for the current platform because I made one for the WASI platform. So I need to say okay, give me the DockerCon, but I want the platform to be WASI, Wasm. If I can write platform. Nice. So now it found the image, but there's an error. And so the error is that Docker on its own doesn't know how to run a WebAssembly module. And because by default, Docker is using runc, and runc only knows how to run Linux binaries. So what you need to do is to tell it, OK, well, I want you to use another runtime when you run this module. So you do that with the -- runtime flag. And then the name of the shim that you want to use. And so in my case, it would be io.containerd -wasm time, for example, --v1. And now if I run this, it worked. So we've built a Docker image that contains a WebAssembly module and gave that to Docker and managed to run. This one is a mouthful, we know. We are trying to find different ways to make it easier for you to just run without having to know, like, io.containerd that I don't know what I mean, it's just insane to have this huge. So we're trying to find better ways. We're not there yet. And just in case you're wondering, these are all the names of the different runtimes that you can use, all the 7 different shims we have. So yeah, I can run it with Wasm time. Let's see, I can run it with Lukic, I think. Yep, works the same. And so like I said, so there are the bare runtimes and then the framework runtimes, which means that if I try, for example, to run this one with spin, nothing happens, because spin needs some configuration files. It needs to be, I mean, the spin image will be a little bit different. I'll show one example just after. Let's see, I have some other examples here. So the Golang one is an easy one, because Golang on its own has everything you need for it to compile into WebAssembly. But in C, it's kind of different. Or in C and in, I guess, other languages, I'm not sure. I know that Rust is also kind of easy to compile to WebAssembly. But like in C, it's kind of more involved. And the way you would do it is the Bytecode Alliance created an image, the WASI SDK, that contains everything you need for you to compile a C code into WebAssembly. Let me just yeah. And so when you have this image, there's this $cc, which is the CLang compiler that knows how to compile to WebAssembly, and then there's the magic C flags that will add all the flags you need to compile also to WebAssembly, and then you just say, okay, compile my main file, and I want a WebAssembly one. So let's see if that works. It's just a simple hello world, right? So it will be the same. It will be Docker build, platform WASI, DockerCon. Let's rebuild, and yeah, we can have the same name. Okay, it built, and let's see if I can also run it with Wasm Edge this time. It worked. Thank you. So yeah, sometimes it's not really straightforward, but there are a bunch of tools out there, and more each day for you to help you to compile things to WebAssembly. Now this is all like cute and all, but let's see something a little bit more complex. I have here a multiple service application. So I'll open this one real quick. Yeah, it's not this one. So in here, we have, what did I do? Yeah. We have a compose file, and our application contains 3 services. One is the client, where we run an Nginx image. The server is our like microservice, and this one will be a WebAssembly container or workload. And then we have the database. And so if I say Docker Compose up here, it manages to open all of them, which, let's see if this really works. If I come back here, localhost 8090, hey, I have my, my application working. So we have 3 different containers here running. There's a database one, a WebAssembly one, which is the server, and then the front end that you see here. Let's see if it works. So order ID 12, 13, quantity a lot, amount, no taxes, I don't know, 12, shipping address, home. And we ordered, and we can see, I guess if I refresh, is it this one? I think. So yeah, the front end called the back end, which is a WebAssembly module, and then we store that in a database. So yeah, you can, as of today, start to use WebAssembly things and put them inside your existing applications. You don't need to reinvent the wheel. You can use the tools that you know and love. Awesome. One interesting one, yeah, I wanted just to show you the WWS demo. This runtime is one of the more interesting ones. So like I said, the WWS, I think they compile Ruby, Python, JavaScript, and a bunch of other languages to WebAssembly. And so this image is kind of different. So in there, you don't put your module, but you put your like source code, Python and JS source code. And then you can use the WWS to install runtime. So here I'm installing the Python runtime. There's no need to install the JavaScript one because it's already pre-bundled with the WWS. So yeah, we're copying WWS, we're copying some configuration files and our source code. And let's just see quickly. So the code is, the WWS is mainly used, I mean, you can, yeah. When you use WWS, you have listeners, like, yeah, they create HTTP responders. So here, basically, we're saying, OK, when someone calls us, I want to reply with something. And in this case, we'll just return some HTML. And the same for Python. You define a worker that will receive a request, and you return some HTML. Let's see how this works. I really think it's interesting what they did, and it's kind of awesome to say, oh, hey, my language is compiled to WebAssembly. OK, I'm going to build this one first. Oh, it's downloading. Oh. Let's wait a bit and hope that the Wi-Fi works. It does. OK, now if I run this, OK. Name. Give me just a second. OK. So it's loading the 2 routes, so the Python one and the JS one. OK, everything is loaded now. And let me see. Yeah, the port is 3000, and then hello.js, for example. OK. So if you call the hello.js route, we have the JavaScript file that runs in WebAssembly that responded. And if I say hello Python, we have the Python script that responds. So yeah, your code isn't compiled to WebAssembly, but your language is compiled to WebAssembly. Why not, right? OK, one last small demo, which is this one. This one comes from our friends at Fermion. They made a CMS for WebAssembly in Rust, and basically, if you go to any Fermion page, it's Bartholomew that responds. So I took their starter and created a small little Docker file. I'm taking the Bartholomew WebAssembly, which contains like the whole CMS, giving it the same entry point. So like I said, Spin is like a framework more than just the WebAssembly runtime. So it needs some configuration. Let's see quickly. In the configuration, basically what it says that this application has one component. This is the source, some ID, and it needs, of course, it's a CMS. It needs some files in there. And the WebAssembly module will be triggered for, I guess this means any route. So yeah, it needs all those files. That's why I'm copying all the files inside my image, and also the WebAssembly module. And for this one, we're not going to use Docker. We are going to use Kubernetes to deploy it. Now, I am not at all an expert on Kubernetes, but I came up with this. It works. So I'm creating a deployment, giving it a name. I have absolutely no idea what this does. Same from here for here. But OK, I do understand this one. So I want one container. I'm giving it a name. I want it to run my image that I built. I won't rebuild this one, but this one is already on Hub, so you can also try to use it on your own machine. And this is the different thing you need. When you want to run WebAssembly modules inside your Kubernetes, you need a special runtime class. So it's the same as with Docker when you say, oh, dash runtime, I want you to use this one. Here I'm telling it, OK, I want for this container, I want this runtime. And the way you install a runtime is another YAML file, I guess, with the runtime class kind. And it's saying, OK, when someone asks for a Wasm time spin, I want you to use the handler spin. And I think I understand what is going on. Basically, the handler's name is spin. And I guess containerd then inside will look for the io.containerd.spin.v1 runtime. I think that's how containerd works, containerd, Kubernetes. But again, I'm really not a Kubernetes expert. Right, so let's go inside the BERT. I have, before we started, I started a cluster. I have one cluster running locally, and you need some pre-setup also. And I would really, if you want to test things out, this is an awesome tool that people created, and it lets you install everything you need inside your Kubernetes cluster so that you can run WebAssembly things. So yeah, you can use it pretty much anywhere. So I have a kind cluster already running, and I installed the Wasm operator. So you can then apply my deployment here. OK, it's unchanged because I already added it. I forgot to remove it, sorry. No, let's see, OK, get all. And we can see, yeah, we have a deployment here, our BART, and there's one ready for us to test. Normally, I guess in Kubernetes, you also need to have like a service or a load balancer or I don't know what, but I'm just going to use this forward. Yeah, the magical command line where I ask, OK, I want you to port forward for the deployment BART, and I want you to deploy the port 80 where Bartholomew is listening to my local host on port 8080. We start the port forwarding, And we have our WebAssembly CMS, thank you, running in Kubernetes. And let's see. OK, we're nearly there. You can soon all go to eat. Where am I? Yeah. Join us. If you see a runtime that you don't see inside Docker Desktop and you want it, come talk to us. If you want any feature about WebAssembly, we have a Docker roadmap repository on GitHub where you can add issues. And also, there's the Run WASI project that we are working on with Microsoft and with Intel and with other companies. The Run WASI project is actually the project that helps all the runtimes create the shims so that we can use them. And so we are actively working on that, helping everyone. And also, we have a WebAssembly channel in our community Slack. Come and say hi. Thank you, everyone, for listening to me. And we have some time for questions. So if you have any question, there are microphones here, or I can just repeat after. Yeah.
Thank you very much for the demo. So one question, one thing that I like about Docker is the layers, right? So you have like a huge project and you change like an HTML file, only one line. Mm-hmm. It won't build an entire Docker image. It will use just a layer.
Yeah.
And here seems like you are building a binary every time you build an application. Is that the binary is going to use layers in any way? Or is it going to be always a huge binary every time you build the entire application?
Yeah, so that's a great question, and it's something I didn't talk at all. If you look at this here, each of the copy commands creates a layer, and only the last layer has my module. So the way we create WebAssembly images today is the same as the normal container images. But there are some people are working on something else because there will be in the future, I think maybe this year or maybe next year, there are like WebAssembly components that are coming. So we are thinking about different ways we can package all of that. So maybe instead of having layers for the WebAssembly components, maybe have them aside and then also have layers for the...
Right, like the actual code be a different layer.
Yeah,
the assets.
A special layer so that we can also like remove it completely from the rootfs of your image. And there's also, I saw there's a bunch of things where you can virtualize your file system for WebAssembly, so you don't even need actually your rootfs. It can also be like another component that you run that gives you like a VFS. But it's all pretty new, experimental, and we're kind of working on that. But yeah, today you have the same things that you will know about layers and works also for WebAssembly.
Got it. Thanks.
Thank you.
Does compiling unsafe languages like C to WebAssembly solve some of the safety problems that they have, like through the security layer of WebAssembly?
So I would say yes, because yeah, the WebAssembly it's a sandbox, and it's just a calculator. It doesn't do anything by its own. But then, of course, if you have code that talks to your file system or to the network, well, there might be some issues. But the cool thing is that you can really like granularly say, okay, I want it to be able to access to this, and that. But yeah, if you only have like WebAssembly that, I don't know, crunches some code, yeah, I think you're way more secure than.